Hi, I'm Peter Cooper and we're going to have a quick look at Ruby symbols. So if you had to pick an all-time most asked question from the different Ruby groups, Stack Overflow, etc., it might be, what are symbols and why use them instead of strings when you're in Ruby? Well, this is what symbols look like. These are symbols, but we can't just finish the video there. I have to actually give you a good answer, and that is that in Ruby, they are scalar value objects that are used as identifiers. They map immutable strings to fixed internal values. That all kind of sounds a bit like BS, really, doesn't it? Let's go to someone perhaps a little bit more wise than me. Back in 2005, Ruby veteran Jim Wyrick said he would love it if people referred to symbols and said symbols are objects with names. But if I had to bust it down to the simplest level, I would kind of say they're values with names. They're kind of values and objects at the same time. So let's have a look. Number 42. This is not a symbol, this is just number 42. But in the real world, we use this as a symbol. It's not 42 particular things, it just represents the concept of 42ness. We use the number 42 where we want to represent that we have 42 of something, or that our age is 42, or any kind of situation where that number is required. It stands in as a symbol for that quantity, or ordinality possibly. Now likewise, in something like Ruby, the symbol West is a mere identifier for the concept of Westness. It's not actually West or the word West itself. Now if you come from a language like C, you might have played around with making your own equivalents of symbols, like with constants and things like that, or compiler definitions like this, where when you use the term Monday or Tuesday or Wednesday, it gets automatically uses the integer 1, 2, or 3 for each of those things. So that in your code you can say Monday, Tuesday, Wednesday, but behind the scenes it's represented by numbers. It's more efficient. It's kind of a bit like the symbol concept that we're talking about. You may have also used something called enum, which gives you a similar arrangement that's a bit more dynamic and a bit more scoped. But this is all philosophical gobbledygook, right? So we're going to dig into a bit more to get a better feel for all of this. So we'll have a bit of a practical here. Look at how things actually work in the real world. So when you're working with interpreters, compilers, things like that, they often have this idea of a symbol table. And what a symbol table does is it stores all of the names of different things that an interpreter or a compiler knows about. And then alongside those, it can store a varying type of information, depends what sort of system you're working with. But let's say in this case, we want to store a symbol, the ID of that individual symbol, and we also want to store what does that symbol point to, like as a variable. So if we say something like x equals 10, where is 10? Where is it pointing to? So let's just move on. You'll get the feel for this as we go. So this is Ruby code now. We'll say x is equal to the string hello. Well, what happens at this point is Ruby creates a string object that has the value hello stored within it for now. It comes up with an object ID for that. It's all stored internally. And then what it will do is it will also create a symbol, x, because that's how we've referred to it. It will create a symbol, and a symbol also has an ID, and then it will say that that symbol with that ID kind of is linked to or points to, and that isn't the official term, I've just come up with that for this table, but it points to that object. So if we have a look at how that works, we've got the symbol x. The symbol x actually on my Ruby interpreter has the ID of 417448, but then I've come up with a random number which represents the object ID of a string that says hello in it. So we're separating the concept of x and the string hello. So x merely points to that string hello, and that's the object ID at the end. Well, now let's do the next one. Let's go y equals 50. So we create another symbol, y, and y has an ID of 438248 on its own. And the number 50, because of how things work in Ruby, has an object ID of 101. So let's carry on a bit more. Now let's say z equals 50. Now z as a symbol, it's a different symbol from y, so it has its own ID, 471848. But 50 is pretty much, in Ruby, it's still an object, but it's an immutable object. It can't be changed. You can't make 50 51. You end up with a totally different thing. So it's kind of a primitive value from the Ruby point of view. So it's the same object. So the points to is the same here. We get the same object ID 101 for both because y and z are both 50. So they're both pointing to the number 50. Now let's shake things up a bit. Let's say A equals X. Now this varies a lot depending on what language you're working with as to what happens here. But in Ruby, when you say A equals X, let's see what happens. All we do is we say, right, we want A, the symbol A, to point off to the same object that X does. So that very same hello object in memory gets pointed to by A. It doesn't duplicate it or do any magic like that. It just takes that object ID and brings it across so A will refer to that as well. So now let's carry on. Let's do B equals hello. Well, this is an all-new string object. This is not the same hello object as X and A are referring to. So it has a different object ID. You can see in the last column there on the symbol table, totally different object ID. And you might think, well, why is this? And the reason for this is that in Ruby, strings are mutable. This means that you can change them. You can add extra content onto a string. It's the same object, but it has a different value text-wise. So we're actually going to do that. We're going to take out A, and we're going to say append to that string, comma, world, so it turns it into hello world. Well, now X will equal hello world, A will equals hello world, but B will still equals hello because it's a totally different object, as we can see from the object IDs in the last column of the table. So let's take all of these simple variable names we've got here. These are actually symbols. These are represented as symbols internally within Ruby, and that is what Ruby's symbol feature actually allows us to access and play with. So on the symbol class there is a method called all_symbols, and what we can do is it's got tons in. I mean, when you run up IRB or something like that, there'll be over 1,000 different symbols already defined because of all the libraries it's loaded and stuff like that. So what we'll do is we'll just look at the size of them. So let's say, when we start out, there's 1,234 symbols. We next define a variable. It's got a brand new name, blah, 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 equals 1, 2, 3, 4. We check how many symbols there are again. There's 1, 2, 3, 5. There is now a symbol called blah, blah, blah that exists on the symbol table. So symbols kind of represent values, and the strings that you see, like the colon, whatever, kind of represent the symbols. So there's a bit of a relationship going on here. Now, something that's well worth getting into your head is that two symbols, if they have that same string identifying them, so in this case, X, that symbol on the left and the symbol on the right are exactly the same object. They have the same object ID in memory. They are the same thing. But if you remember from before, with the strings, a string of X and a string of X, if you just define them like that, if you use the double equals in Ruby, it will say they're equal, because what it's doing is it's actually looking at the content of the string and it's saying, oh yeah, X is equal to X in a textual way. But if you look at the object IDs, they're totally different objects within memory. So they are not the same thing. And if you are familiar with Python, for example, this may be slightly confusing, because in Python, you can actually use strings in the way we use symbols in Ruby, because in Python, strings are immutable, so you don't have this whole problem at all. So, what can symbols represent? Well, there's a whole ton of things they can represent. In Ruby, it's very common to use them for method names and things like concepts and shapes and parameters that you send in and things like that. It's just tons and tons of stuff. We're going to look at some examples in a minute. But the key thing to bear in mind is they are used for unique identifiers. They're not used for data. So if you've got a string that's coming in from a database and it's, random stuff, or it's stuff that's been typed in on a website and someone clicks submit and it's come in, it's not used for that. Those are strings. Those are just dynamic textual data. We need these for identifiers. They identify concepts. Very small, limited vocabulary is a way I've explained it before. Whereas strings are more kind of free-form data, user-supplied data. Now, back in 2007, Jim Warwick, again, that name again, he said, if the textual content of the object is important, use a string. If the identity of the object is important, use a symbol. I totally go along with that. Definitely think that's the way to go. Now, I was reading through David Black's very, very fine, well-grounded Rubyist book, just to see some of the stuff that he had to say about symbols. And I came across one of the examples in his book, and On its own, it's correct, but there's a slight flaw in it, and I kind of want to leave this as an exercise to you to figure out what's going on here. So very similar to what I was doing earlier, he was saying symbol, all symbols.size, getting a size, creating a variable called a, checking the size has increased because there's now a symbol called a, and what he's doing is he's saying symbol.all symbols, so return that array of all the different symbol names, does it include a? And it does. But the thing is, if you take that line at the end, symbol.allsymbols.include, and you put any symbol name in there, so even a symbol name of something, variable that doesn't even exist, so just, Quijubo or whatever, it will always return true. Why is that? I could explain why, but I just want you to have a little challenge there. So why would it do that? Leave it as a comment or on the forum if you're on the course, that type of thing. So let's actually talk about making symbols. So here is a symbol, : gender. Now, you can't put spaces in because otherwise how's it going to know where the symbol ends? It's just, simple word. You can have underscores in, you can have numbers within it, all that type of thing, but very, very simple. But if you do want to kind of make it a bit more string-like, while still being a symbol, you can use your colon and then use your quotation marks and then put in whatever it is that you want. But I would not recommend ever using symbols with spaces in because it just gets horrible the way to notate them. Try and stick with that notation if at all possible. Another way to do it is just take a normal string and then go to sim. Now, you wouldn't normally do it in this way. If you were in some code, you would use to sim to convert a string that you don't have control over into a symbol. You wouldn't do it with a literal like this because otherwise you might as well just type : gender in the first place and save all the kind of the memory problems of duplicating strings all over the place. So just keep that in mind. Another one that you can use is .intern, and the whole concept of taking a string object and then turning it into something internal and that has a one fixed value is often called interning in various languages. So that concept is in Ruby as well. Another way to do it is to use %s, and this is a bit like where you can define arrays with %w or strings with %q, that type of thing. Well, %s gives you another way of turning a string into a symbol, essentially. So that will also create the : gender symbol. Now, what about the other way around? We want to take a symbol, turn it back into a string. Just do it with this, 2s. Converts anything into a string. Perfect. Alternatively, you can use id2name. I think this kind of dates from the internal names of the functions that are within the main Ruby interpreter for doing this type of work, but I've not actually seen people really use this much in the wild, so don't worry too much about that one. I just use 2s personally. So let's go into some common uses for symbols. What can we do? Well, we're going to do this live because getting bored of me chatting just about stuff. I'm actually going to show you some examples live. Okay, before we get too far with this, I want to really stress that whole point about symbols being more efficient than strings. So let's take a string, for example, hello, and what we'll do is we'll just quickly see what is the object ID of that string. Okay, seems fair enough, but if we keep repeating it over and over, we can see that it has a different object ID each time. And the reason for that is because there's a string in memory being created each time, hello, hello, hello. They're all different objects. And the reason for that, as I mentioned before, is because strings are mutable. They can be changed. If we do the same thing with symbol, and we check its object ID, you can see it's always the same ID. You think, okay, interesting, but why is that important? Well, let's say we've got a concept of a user in our system. We're just being scrappy here. We're using a hash to keep track of them, and we're creating something like this. So we've got their name, so we've got Fred, we've got their age, 10, something like that. So it's a simple hash mapping keys that are strings to values that may be strings or other objects, anything. So we've got that. Now, imagine if we had, say, I don't know, several thousand of these. What would happen is all of these name and age strings here, because strings are mutable and can be changed in Ruby, these would keep being created as new objects. So even though every single one would have the key of name and the key of age, each of those individual strings representing the concepts of name and age in each of those hashes would be created afresh. And we can check this by going user.keys, so that gets us the name and the age. And then what we'll do is we will map the object ID in. So, okay, that looks good. We'll create another user, exactly the same name, exactly the same age. Oops, I made a mistake there. I didn't put user 2. Okay, now you can see what the problem here is that between these two different comparisons, they have different IDs. So if you had thousands or even millions of different users in this system, you'd be duplicating needless stuff with the name and the age. Let's go back and make a change. We will use symbols instead. And this really is the whole motivation for why you would use symbols. Not least because, they kind of have a semantic difference and they look different in the code, but because of this efficiency angle. So now what we'll do is we'll do user keys map and user 2 keys map. You can see that the keys are based on the exact same symbol objects every single time. This makes them super efficient, and this is one of the main reasons we use them. So I've kind of shown you off actually one of the first main uses for using symbols. It's because you can use them as keys within hashes. That's very useful. This pattern of using symbols as keys for hashes is so prevalent that Ruby 1.9 actually added some stuff to make the whole system a lot simpler and to give it a slightly nicer syntax. Although there are many that disagree with this. But all you do is something like this. See, even I'm making it wrong. So in this case, you would still use symbols to do the lookups, but you can see up here, instead of using symbols, we've just used text, but then put the colon after. And this is a more kind of common syntax that you'd see in something like JavaScript or Python. There's a lot of experienced Ruby developers who do not like this syntax, but just be aware you may bump into it and you may well wish to choose to use it yourself. Let's bring up an editor. So we've already noted several times now that symbols are just regular Ruby objects, so they can be passed around just like any other object. So you're sure to have done something like this already. So we've got a user class, and in here we've got @accessor, we've got things like name, age, gender, all that type of thing. And then you might want to create a new user, and you can set information upon them like so. And what we'll do is we'll just print out everything that's in thread, and as you can see, we get what we expect. @accessor is just a method that is on the module class, and what that does is it creates accessor methods and getters and setters for us. Name equals name, age equals age, and gender equals and gender. And all we're doing is passing in symbols, and bam, it works. So that's a very common use for symbols, is just to use them when you're passing stuff into methods that are, as we've said, from a limited vocabulary, something along those types of lines. Another instance where you might use this, if I just delete this and go over to the IRB again, if we've got something like, let's say, a string, and let's say we want to ask it, do you respond to length? It's a little bit crammed in here. What we'll do is expand that. So we'll say, do you respond to length? And it says true. Do you respond to Zuzi? No, you don't, because that method doesn't exist upon hello. So this, again, is just a method that's within Ruby on the object class, and it just takes a symbol and then it returns true or false depending on whether the object will respond to that message or not. Or in layman's terms, whether it will respond to run that method or not, whether that method exists upon that object. If you've been using Ruby for more than a trivial amount of time, you may be familiar with the concept that if the last argument that you pass into a method is a hash, it doesn't have to be notated as a hash literal. So for example here, I've got a very simple method called my_method. It has 3 required parameters come in. We have a, b, and options. So when I now invoke that method, I'm passing in 1, which will go to a, 2 that will go to b, and I've kind of definitely, literally put down a complete hash here to pass into options. So if I run that, no surprises, what is in here? It's the hash. Well, you may know that, of course, you don't actually need to do that in Ruby. If something looks like a hash at the end of a method call, it gets treated like one. And so this is often used for doing things like named parameter type adventures, so that still works. But you might remember that 1.9 syntax that I was showing you about with hashes. Well, again, all that works here as well. If we change that over, this looks a lot more like a named parameter system that you might have seen in other languages. So this is very attractive. And of course, we don't even need these required parameters here. You can have your entire call be done in this way. Almost looks a bit Objective-C-esque, which is kind of cool, and has been used to that advantage in several frameworks. One particularly intriguing and slightly advanced use of symbols is in what we call symbol to proc. This came in a project called the Ruby Extensions project, and then it got boiled into Rails, and then eventually actually became part of the core Ruby language, and now you can use it fine, I think, in Ruby 1.8.7 and 1.9 onwards. So let's say we've got an array here. It contains 3 words: hello, world, and test. Well, what would we do if we wanted to, create a new array with all of those words in uppercase? So we might use the map method and do it this way. So we can see here we get all of our stuff in uppercase. Well, this looks kind of, there's lots of repetition here, word, and it's just extra syntax, stuff like that. Is there a quick way of doing this? Well, if you've been using Rails for quite a while and you've been following the style guides and reading the books and everything, you may have seen this type of construction. So if we run that, it does exactly the same thing. And you may notice, having watched this video, that a symbol is being used here. So this is a symbol that represents the uppercase method. But what's this ampersand? Well, the ampersand in this situation is coercing the symbol to become a proc object. And a proc object is something that can be passed off to a method that it can then run however it wants. So the map method will run that proc multiple times to do the mapping from one array to the new one. But back in the old days, before this became part of core Ruby, symbols couldn't be coerced to procs. It didn't really make sense as a concept. So someone, I don't know who, came up with the clever idea that all we have to do is go in, add the method to the symbol class called to_proc, which is what the ampersand coercion will call anyway on whatever object you pass in. And then what we do inside there is we create a proc and we accept an object, and then we use the send method, which will pass a message into an object to run a particular method that is the same as the symbol that we've got. Now, that might sound a bit complicated. I think I might do another video about just this symbol to proc thing specifically, because I'm trying to focus entirely on symbols here. But essentially what happens is that will run uppercase in each case for doing the mapping from one thing to the other. So before we finish our little tour of symbols here today, I just want to cover an interesting point that Ruby 1.9 brought into the mix here. Now, we said earlier that even though symbols are kind of represented by immutable strings, if you look at them from a physical point of view, we've got our colon and then what looks like a string following it, and that can't be changed. It always associates to this one value behind the scenes, as we've seen. Despite that, and despite people saying, well, no, they're not really immutable strings, that's not how you should look at these, Ruby 1.9 added a bunch of methods to make symbols act a bit more like immutable strings, which is rather confusing, and I'm not particularly keen on this. I haven't come across any real need to use this, but they must have been added for a reason, so there's got to be a motivation for this. So what do I mean? Well, let's take a symbol, let's just do A, B, C, D, E, F, that's fine. Well, what you can now do in Ruby 1.9 is you can call certain string methods upon them. So you can get an uppercase version of your symbol. You can get downcase, although that will be the same. You can get the length of the string that represents that symbol, so the A, B, C, D, E, F, 6 characters long. You can even go in and access individual characters from the symbol and access other things like next and stuff like that. I'm not a big fan of this. I'm not sure of the need for it. Just what you should be aware of this, however, though, if you see it in code, sometimes people are kind of trying to use them as strings and being a little bit clever. But I would go back to what we said earlier in the video, and these really are value objects, they're identities of things. So look at them in that regard. And so there we are. We are at the end of the symbols video, a little bit longer than I was expecting it to be, but there is they're very important symbols in Ruby. You need to be aware of how they work and get quite a good feel for them. Hopefully I've given you a reasonable introduction to them, but if you have more questions, just head to the forum and ask whatever you like. If there's things that I could explain better, of course I could do more videos towards that. So for now, thank you very much.